Okay, so we are going to be jumping into Unit 2 of the course. And Unit 2 has to do with mathematical functions. So in the previous unit, we were focusing on inequalities, and we saw linear inequalities, nonlinear inequalities. We talked about absolute value. We'd also talked about the distance and midpoint between 2 points. That's basically rounded out unit 1. Okay. Now in unit 2, we're going to be focusing on mathematical functions. Again, I would say none of what we're seeing in this course should be new for you guys. You should have seen this at some point previously, at any given moment in high school. And so none of this is new, but it's important for us to understand this moving forward in engineering. So let's talk about mathematical function. What is a mathematical function? A mathematical function is going to be a relationship that is defined by a rule set. A rule set of correspondence that assigns values to certain elements. So if we have 2 elements called X and Y, then the relationship that's established between them as a function, if we're going to say that Y is a function of X, it means that for each element of X, we have one exact, only, and unique element of Y. This is important. So there is a one-to-one relationship there between those 2 elements or variables. So I'm going to say it again. A function is going to be a set defined by rules of correspondence between 2 elements or 2 variables, X and Y, where for each element of X, exactly one element of Y is assigned. That's the relationship or correspondence that exists. If for a particular element of X, there is more than one value of Y, then that is not a function. Okay. So that's a very important definition moving forward. And how do we represent it, this relationship? We represent it as Y equals F of X. This expression, this mathematical expression that we have here, is how we define this relationship. Y is a function of X. Y is going to be the dependent variable, and X is going to be the independent variable. So I mean that Y depends on X. And again, only for each element of X, there's only going to be one exact element of Y. And now we're going to talk about 2 very important concepts that are going to be, we're going to be seeing these concepts throughout the unit and for the better part of the first half of the unit. And it's the concept of the domain and the range of a function. Okay. And I'm going to be giving you some tips, some guidelines there, so you can remember, and this is easier for you to remember and to understand the applications and problems that we're going to see. So what is the domain of a function? The domain of a function is the largest subset of real numbers for X for which F of X is a real number. Now, let me simplify that definition. The domain of a function is all of the possible values that X can have for that function. Again, the domain of a function is all of the possible values X, which is the independent variable, can have for that function. Okay. And remember that we're talking about real numbers. Okay, we're only talking about real numbers. Now, there's basically going to be two rules that we're going to follow here of things that are excluded from the domain of a function. And these rules are very, very, very simple, very simple. And I'm going to ask you to remember them or write them down. Things that are excluded from the domain of a function, or things that are values of X that cannot occur. First off is a division by 0. Any values of X where the function generates a division of 0, those are excluded from the domain. Those are not part of the domain. And the other is any values that create a negative even root. So for example, any value of X that generates a negative value within a root that is even, meaning a square root is root to the 4, root to the 6, etc., those are excluded as well. Those are going to be the two conditions that exclude values of the domain. Meaning, and just to note, these here, these are exclusions. So if none of these two conditions occur for a function, it means that the domain is from -infinite to infinite. It means that the domain, any value of X, the function can have, okay? Now, what is the range of a function? The range of a function are going to be all of the possible values of Y or f of X that correspond to the domain of the function. So the function has a domain, which are all the possible values of X. The range is going to be all the possible values of Y for that domain, okay? Questions? We're going to be doing some exercises to practice this, and homework task number 6
Teacher,
is basically, go ahead, Daniel, please.
could you give an example of a negative even root? I didn't understand that one.
Good, let's do that. So let me, we're actually going to see some examples in a moment, Daniel, but let me give one example here. Let's imagine that we have a very simple function here, Daniel. Y equals the square root of X. Okay, that's a function. And I ask you, Daniel, what is the domain of that function? The domain are all of the possible values that X can have, okay? But that is a square root. Can X have a negative value? Daniel?
Yes.
Can it? Can we count the negative, the square root of let's say that I say that X equals -2, and I substitute this here, I'm going to get the square root of -2. That, by the way, that is a number, but it's an imaginary number. We're not talking, we're only focusing on real numbers. So I ask the question again, can X have a negative value?
No.
No. So what is the domain of this function? It's going to be all of the possible values of X that don't generate a negative root. This would mean that the domain is from -infinite to, the domain is from 0 to infinite. Now, Daniel, is the 0 included or not? Is the 0 a possible value that X can have? Yes or no?
Yes.
Correct, because the square root of 0 exists. The square root of 0 is 0. But I can't have any negative values. And so the domain is from 0 to infinite. Was that clear?
Yes, teacher, thank you.
Yeah, let's give another example here. This is an example of the negative even root. Now let's give an example over here. Let's say that f of x. I'm sorry. That's the same thing. Let's say that y equals 1 divided by x minus 1. Okay. Let's see. Fernanda. Are you there, Fernanda?
Yes, teacher.
Okay. Remember, if you can turn on your camera when you're participating, that'd be great. So Fernanda, we're looking, same as I asked Daniel, I want to know the domain of this function. And the domain of this function are all of the possible values of x that are valid. I ask you a question. What value makes the denominator 0 here in this function?
1.
1. So x equals 1 is going to generate y equals 1 divided by 0, right? And that's something that cannot happen. So would you agree, Fernanda, that x equals 1 is not a value that's possible for this function? So how do you think the domain would be for this function then?
It will be, it has to be greater than 1.
Well, if I say that it goes from 1 to infinite, I'm excluding the negative numbers, right? But Fernanda, can x be a negative number there?
Yes.
Yes. So what is the only number that I can't put in that function?
1.
So the domain is all of the numbers that exist except
1.
Okay, how would we write that, Fernanda?
Parentheses, negative infinite, comma 1, parentheses,
Correct.
the u,
Correct.
and parentheses 1, comma infinite.
Perfect. That is the domain of this function. It's going to be all of the possible values except the value that invalidates except the value that invalidates the function. Thank you. Was that clear, Fernanda?
Yes.
Thank you very much, Fernanda. And so with these two examples, just remember, it's actually very simple. When I ask you to calculate the domain of a function, the only thing we need to do is look at the function and, okay, is there a root? Is there an even root? Okay, so the numbers that make the even root negative, I have to take those away. Is there a quotient? Is there a division? Anything that makes the denominator 0, I have to take those away. So it's going to be all of the real numbers, and I'm going to exclude those values that create a negative even root and a division by 0. And that's going to be the domain of the function. Okay, is that clear? Any questions up to this point before I jump over to, so we can see some examples? No? Okay, I'm going to clear that. Basically, homework task number 6, it's basically to do this, and we're going to see some examples right now. I'm going to clear this, and I'm going to jump. Let's look at this function. I'm going to be calling on some of you to help me out, okay? Find the domain and range for y equals f of x equals x squared. What the domain? Let's find the domain first. Let's see, Joel. Help me out here, Joel. The domain of that function, y equals f of x equals x squared. What is the domain? What do you think the domain is? What are the possible values of x?
Well, it can be from minus infinite to infinite. No, it can be all the numbers.
That's correct. That's correct. Can you please explain? That is correct. Can you please explain what was the logic there?
Well, I think that you can choose any number because any number has a square and it has a real number.
Correct. Now I'm going to ask you, and I'm going to be doing this to reinforce what I just said in the previous slide, because again, these are guidelines and tips and rules I'm giving you, so you guys can understand the problems a little bit better. I'm going to ask you two questions. The first one, in the function, is there a root somewhere in the function?
No.
Nope, right? Is in the function, is there a denominator? Is there a quotient where we have a denominator where there are variables there?
No.
So according to what I just said previously, there are no restrictions, right? And since there are no restrictions, then the domain is from minus infinite to infinite. Correct?
Yes.
Correct. Thank you very much, Gordon. That was great. Now it gets a little bit tricky because with the range, there aren't any rules. We have to do a bit of an analysis there. Can somebody, now we've got the range. The range are the possible values of y. The range are the possible values of y, but for the domain that we established for x. Can somebody guess what is the range for this function? Meaning for the values of x that we established, that Joel just said, what are the possible values of y?
Is it
I just say more of the domain, no?
Nope.
all the positive numbers?
That's correct, Daniel. Why? That's correct.
Because every negative squared will be a positive because of the sign rules, and every positive square stays positive.
Correct. So you're saying that the range would be from 0 to infinite. Would we include the 0 or not?
I think so. Yes, I'm not sure. I don't.
Well, yeah. This is the answer to the question. Is x equals 0 part of the domain? Look at the domain. The domain is this. So is x equals 0 part of the domain? It is. If I substitute x equals 0, what do I get?
0.
0. So 0 is part of this. So the observation that Daniel was making is correct. Okay, if I grab it, and this is a tip, this is another tip when you're analyzing domains and ranges. The first is to define the domain. And once you have the domain is going to be established. It's going to have certain reference points. Here, for example, a reference point, if we have from minus infinite to infinite, it's for one reference point is the negative numbers, the other reference point is 0, and the other reference point is the positive numbers. So what Daniel said is, okay, if I substitute a negative number, what do I get? I get a positive number always because I have the square. If I substitute 0, I get 0. And if I substitute the positive numbers, I get a positive number. That means that the range is going to be from 0 to infinite. Okay. For the range, we're going to have to do a little bit of analysis. Okay. And basically, we haven't seen graphs and plots yet, but the analysis, we can do it by substituting some values of the domain. Okay. Questions with this one? Are we okay up to this point? Okay. Let's go on to another one. Remember, if you have any questions, just open your mic or raise your. Now I'm going to give you a minute to look at this one. Now we've got find the domain and range for y equals f of x equals 4 plus the square root of x minus 3. And what are the possible values of x? That's going to give us the domain. And what are the possible values of y? Okay. I'm going to give you a minute to kind of chew on this one, and then we're gonna solve it here.
Teacher,
Okay, let's look at this one. Let's see, who can help me out here? Let's see, Ivan.
Yes.
Okay, let's look at this. Put me on the screen. There we go. Let's look at this function. We've got y equals f of x equals 4 plus the square root of x minus 3. And we want to find the domain. The domain, again, are going to be all of the values, all of the possible values of x. How do you suggest, or how do you think we could approach this, Ivan?
I think we have to not include number 3 because it would give us 0. Is that correct?
Well, let's analyze that. We have a square root there, Ivan, right? There, remember, and I'm gonna be saying this a lot, so you guys hopefully remember. Remember the two rules. The rules have to do with even roots, and they have to do with quotients that have a denominator. For the square or even roots, we can't have negative values. For the quotients with a denominator, that's where we can have a 0 value, okay? So let's look at this one here again. What do we have there? We see that we have a square root, right, Ivan?
Mm-hmm.
So what would be the restriction then?
3, number 3, we can include number 3, so it would be from minus infinite to 3 and from 3 to infinite.
No, we can include Ivan, the restriction. The restriction has to do that we can't have a negative number inside the square root. We can't have a 0. We can't have a negative number inside the square root. Okay? Are you okay there, Ivan? I think your mic got cut off. Did your mic get cut off, Ivan? Ivan, are you still there? Ivan? Your headset died. Okay.
Okay, can you hear me now?
Yes, I can.
Sorry, I didn't hear anything of what you just said.
Okay. We're coming back here, Ivan. Again, we're going to stay with you, okay? The square root of x minus 3. First off, a square root can be 0.
Okay.
So 3 is a valid value. What is the restriction, or a square root cannot be what?
It cannot be negative.
It cannot be negative. So whatever is inside this square root
Has to be positive.
has to be positive, correct? So whatever is inside this square root
Okay.
has to be positive. That's a very good way of saying it, Ivan. Now let's try to link things up from the last unit. can we represent that as an inequality, Ivan?
Mhm.
How could
X
we?
should be bigger than 3.
Yeah, let's do it this way. If you agree, Ivan, x minus 3 has to be larger than or equal to 0. This is very important, you guys, because we always have this. I always have this trouble when we're working functions with first semester students. A square root can be 0. It can be negative. Okay, so x minus 3 has to be larger than or equal to 0. That means that x has to be larger than 3, right?
Yes, yes.
Which means that the domain is going to be, can you give me how would we represent the domain, Ivan? And I'm going to let you go after that.
We have to include number 3, so we would use a corchete. I don't know what the name is.
That's called a bracket.
A bracket,
Mhm.
and then we can write comma infinite, and then we close it with a parenthesis.
So it's bracket 3 comma infinite.
Yes.
Correct. Was that clear, Ivan?
Yes, I get it now.
Okay, perfect. Thank you, Ivan. Daniel, you had raised your hand.
Yes, is that I knew the answer for both the domain and the range.
Okay, then help me out with the range. It gets tricky with the range. It gets tricky
Yes.
with the range. Now, what would you say? What can you tell us about the
Well,
range?
what I reasoned is that the domain is defined by the square root. So that means that, well, in this case, the range is defined by the 4 plus. So since
Mhm.
the square root will always be from 0 to a positive, it can only be the range. It will be from 4 to infinite.
Good job. Good job. That's a good job. That's a great analysis, Daniel. So let me walk through what Daniel just talked about. The range is going to be all of the possible values of y according to the domain we just defined. So if we just defined a domain that goes from 3 to infinite, and why did we do that? We did that because of the square root. That means that the values here are going to go from x larger than or equal to 3. If I substitute the 3 here, so meaning for x equals 3, then the square root is going to be 0. For x larger than or equal to 3, the square root is going to be also larger than 0. That means that this value here for the domain that we defined is going to be larger than or equal to 0, right? So that means that I'm always going to be adding something to the 4. So it's going to be 4 plus something, 4 plus whatever I'm substituting here. That means that the domain is going to be from 4 to infinite. Now, do we include the 4 or not?
Yes.
Yes, we do. Correct. Because this means what we were just talking about over here. This means that in this case, y is always going to be larger than or equal to 4. Okay, that was a good analysis there, Daniel. Okay, good job. Questions with this one? Better part of homework task number 6 has to do with this, domain and range. And remember that homework task number 6 is already in Blackboard. I'll let you know in a minute. I think it's for next Tuesday. Remember that there's tutoring today and on Thursday with Estrella. I sent the updated, I had made a mistake with the Zoom link for the tutoring sessions. I apologize for that. The latest and updated Zoom link is the one I sent in the chat last week. Okay, so questions with this one before we move on. Okay, I'm going to clear this. I'm going to jump over to the next one. Now let's look at this one. Let's see who can help me out here. Anna. Hi, Anna.
Hi.
Are you at SETIs?
Nope.
Oh, I thought because of the, I thought the wall. Sorry about that. Okay, Anna, let's look at this one now. We have y equals the square root of x squared plus 2x plus minus 15. Okay. How could we approach that one? What are we seeing there?
Well, we have an x inside the square root, so
Correct.
it's different than the other one.
So we've got something here inside the square root. And when I'm saying something, it has to be everything that's inside the square root. What is the restriction that we're going to have with the square root?
That it has to be a positive number.
Correct. All of what's inside there has to be positive. Are we okay up to that point, Anna?
Yes.
Now, it's important to link up what we've seen in the previous unit. How can we represent, could we represent that as an inequality, Anna?
Yes.
How could we represent it as an inequality?
Let me think. I mean, I know we can do it, but I'm not sure how.
Well, let me help you out there, Anna. It's going to be relatively simple. I think I lost you here. Oh, there we go. I just wanted to see you on the screen. It's gonna be relatively simple. Are we okay up to this point where what I drew in red has to be positive? Do you agree with that?
Yes.
How do I represent with an inequality that something is positive?
Oh, with the sign.
Mhm.
So it's gonna be square x
Mhm.
plus 2x minus 15
Mhm.
and is greater than 0.
Perfect, Anna. That's great. Well, question, greater than or equal?
Or equal.
Correct, because remember, the 0 is included. Perfect. We just represented it as an inequality. Do you remember how to solve these inequalities, Anna? We just did that last unit. What do we have to do there?
First we already have the equal to 0. So we can,
We just did this in last exam. This is a nonlinear inequality. What's the first step?
I'm in blank.
Don't worry, it'll come
Yeah.
back. It starts with
Okay,
R.
okay, I know.
Hmm?
The first thing that we need to do is factorize.
It starts with
Roots.
R. Exactly, the roots. Okay. And can we factor something here? I think
Yes.
we can. I think if we put a 5 here and a 3 here, this would be positive and this would be negative, right?
Yes.
And would you agree then that the roots are x equals 3 and x equals minus 5? And then we would have intervals. What would those intervals be?
It would be -5, 3.
Would be, well, no, remember we've got,
Infinite, negative infinite, comma, -5.
hmm?
And then the other one, 3, comma, positive infinite.
Well, we include the -5 and then we go from -5 to 3. Then we include the 3 and then we go from 3 to infinite. Okay. And we could use the sign chart if we wanted to. right? That's how we did it last unit, okay? We could use the sign chart. And we're gonna do that very, very quickly here, Anna, and you're gonna help me out just so we can practice, okay? We're practicing here. X minus 3, X plus 5, and X minus 3, X plus 5. Okay, just so we can practice, okay? Anna?
Yeah.
And while I'm writing this down, you can start kind of looking at what the answers are going to be. And remember, we're kind of practicing what we're going to be needing what we saw last unit in these exercises, okay? There's actually a very simple method where we can find the domain of a parabolic function. We're going to see that in a bit. Here, Anna, help me out so we can fill this in real quickly. X minus 3. Go ahead.
Negative,
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 negative, negative,
negative, and 0,
0, and
positive,
positive. It's going to switch over automatically. Now over here,
negative, 0,
hmm,
positive, positive, and positive,
perfect. Minus times minus,
positive,
minus times 0,
0,
minus times plus,
minus,
0 times plus,
and plus,
now 0,
and
and plus times plus is plus. Now, Anna, what would be the rate? What would be the ones that we're going to be using then? What intervals?
we're going to be using negative infinite until negative 5.
Included or not? The 5.
Yes,
Brackets. Union with.
with 3 until positive infinite.
Included or not, the 3.
Yes,
That would be the domain. Perfect. Was that clear?
Yes.
Anna? Perfect. Perfect. Well done. Well done. Well done. Thank you, Anna. Let's see. Andres, you there?
Yes, teacher.
Okay, perfect, Andres. First off, questions with this first part. Was it relatively clear what we did?
Yeah, I understand.
Okay, perfect. Now, if we understood that, now let's look at the range, which starts to be a little bit tricky, but let's look at the range. And remember, the range is going to be all of the possible values of y for the domain that we just established. So if we substitute these values here, what are going to be the values of y? Now, how do you think we could approach that, kind of looking at the function that we have?
Well, maybe we could calculate the values with 3 and minus 5, and then well, depending on the value, we could establish something like an inequality.
Okay, let's go with that. If I substitute the minus 5 or the 3, those are roots, Andres. So the roots are always going to give me a 0. So that's a good starting point. If I substitute the minus 5 and the 3, everything that's inside the square root is going to become 0. Okay? That's a good point. So 0 is a reference. If I substitute anything, let's say that I substitute a number that is here in this range. Choose any number.
Minus 6.
minus 6. Let's say I substitute minus 6 here. Notice something here, Andres. I'm really not that interested in the specific value. I'm kind of interested in the signs. If I substitute a minus 6 here, try to do the calculation very quickly. 6 squared. 2 times 6 minus 15. 6 squared is 36. Plus 12 minus 15. What does that give us?
33,
33. Is that positive or negative?
positive.
Positive, right? Okay. Choose any number that is in this other range from 3 to infinite. Choose any number you want.
5,
5. Do that calculation very quickly there on this. 5 times squared is 25 plus 10 minus 15. What do we get there? It's 20, isn't it?
20,
20. So if I substituted minus 5 and 3, I got a 0. And if I substituted any other number in the range, I got something positive. Therefore, what do you think the range is then?
that y is greater or equal to 0.
Perfect. Perfect on this. The range is going to be from 0 to infinite. So for any value I give it, I'm always going to get a positive value. I can't, we kind of did an analysis here, but it's a square root. So I'm not going to be getting a negative value there. Okay. Was that clear, Andres?
Yes.
Okay, perfect. Thank you. Thank you very much. Thank you very much. Okay, perfect. I'm going to take a screenshot of this because I like the way this came out.
Teacher,
Yes, go ahead, Daniel.
is it the same thing as the rule for the square roots?
Kind of, yeah. So if you've got a square root from y, you're not going to have a negative value. So right now we just have the square root. That's why it's giving us a positive value. If using your same logic, if, for example, I had a plus 2 here, then it would be from 2 to infinite, like we did the other one. Okay. But yeah, we kind of, the range is also going to be subject to the same rules of the domain. Okay. Good. I'm going to clear this. I'm going to jump over to the next one. Questions before we move on? Okay. I'm going to give you a couple of minutes to try these out. Find the domain. Find the domain. We're just looking at the domain right now. Find the domain for these two functions. I'm going to give you a couple of minutes to try to do that, and I'm going to call upon somebody to try this out. Okay, let's jump back in here. Okay, let's look at these two problems. I'm gonna call on somebody. Let's see. Let's see, Aime. Hi, Aime. Help me out with the first one here, okay?
I have a doubt. What's the difference between this one and the other one? What do we have to do when we have as a denominator?
Perfect. That's exactly what we're gonna talk about. So help me out here, Aime. First of all, we've got a denominator, right? Aime? We've got a quotient. We have a function that has a numerator and a denominator. And let's remember the two rules. The first rule is that the denominator cannot be zero. Okay? It cannot be zero. Do you remember that? Would you agree with that? So what we have here in the denominator, all of this, cannot be zero. Are we okay up to that point, Aime? But what else do we have in the function?
Square root.
Square root. And what's the rule with the square root?
It has to be positive.
It has to be positive. So what's inside here has to be positive. Are we okay up to that point? So how could we represent that? How could we represent that as an inequality? A similar question that I had made to Anna. How could we represent that as an inequality?
It's that same that we made in the previous problem.
With one little modification, I mean. So I'm going to write it down this way. I mean, what we did in the previous problem, if you agree, we said this: x squared plus 2x minus 15 is larger than or equal to 0, right? I meant that is what we wrote previously. What do we need to modify now?
Equal. We have to delete it.
Correct.
But we can't have a 0.
Correct, I meant. So the inequality is now going to be larger than 0, not larger than or equal. Okay, are we okay up to that point, I meant?
Yes.
And so we don't have to rework. We already solved that inequality in the previous problem, as you noticed. And we had gotten a result in the previous inequality. We had said that the domain for the previous inequality, help me out here, I meant, was minus infinite to minus 5 was minus infinite to minus 5. This was a result of the previous one. Union from 3 to infinite. Right, Aime?
Yes.
What would be the domain for this function?
We have to delete the brackets and substitute by parentheses.
Correct, because now the minus 3 and the minus 5, I'm sorry, and the 3 are not included. So now this would be like this. And that would be the solution. That would be the domain. Okay? Was that clear, Aime?
Yes.
Perfect. Thank you. Thank you. Thank you. Thanks so much for helping me out with that one. That's perfect. Thank you. Let's see. Luis Espinosa. Are you there?
Yes.
Hi, Luis. Okay, so now help me out with the second one that we've got there. We've got another function there that has a quotient. What are we going to do there? How are we going to approach that?
I haven't finished the problem, but it will not be the same, like cannot be 0 on the denominator.
That's correct. That's the first thing we need to identify. This here cannot be 0. How do I find the values that make this 0, Luis?
Like the last problem, I think. It was x plus 4 and x minus 1.
Perfect, you already factored it. So if we bring this over here, I just want to separate this. So if we factor this, so just to be clear, x minus 3x minus 4 cannot be 0. And could you repeat the factors again there, Luis?
X plus 4 and x minus 1.
X plus 4. No. No, we need the signs there. Could you check the signs there? Please,
Yes, yes.
How would the signs be? The factors are correct, but how would the signs be?
X minus 1 and x plus 1.
Correct. X minus 4 and x plus 1. So that gives us x equals 4 and x equals minus 1. So those are the values that make the denominator 0, Luis. So how would we establish the domain?
It will be a negative infinite to minus 1 with parentheses and union with 4 to infinite, also with parentheses.
Correct. Perfect, Luis. Perfect. That would be the domain for the function. Perfect. Well done. Well done. Thank you, Luis. Questions with these two?
I have a question, teacher.
Go ahead, Andres, please.
Can't we include the values between -1 and 4 that aren't -1 and 4?
Oh, wait a minute, wait a minute, wait a minute. You're right, you're right, Andres, you're right. So, Luis, we're talking about this. Andres's observation is correct. I lost my pen. What did I do with my pen? I literally, oh, here it is. That's true. This doesn't have a root in it. So the only values that are excluded are the 4 and the -1. So Andres, how would the result be then? You are correct.
Well, after the -1, you had the union, and then -1 to 4.
Correct.
And then the union. And -4 to infinite. No, sorry, 4 to infinite.
Correct. Thank you for that, Andres. Good catch there. Yeah, the only values that are excluded are the -1 and the 4. Okay, so it's going to be all of the real numbers except those two. Okay, good job, good job. I had some baby brain there and I didn't notice that. Good job. Was that clear, Luis, as well?
Yes, thank you.
Okay, perfect. Thank you. Okay, so questions with these two. Okay, I'm gonna jump over to the next ones. Okay, this is the fun part. At least I really like this because we're gonna start talking about graphing and plots of functions. And I really enjoy this part because it's actually kind of like magic. You can literally, we're going to see some tips and tools where you can literally just look at a function and be able to graph it without having to do any calculations. That might be useful, kids. That might be useful at some point. That might be useful. Daniel, go ahead.
Teacher, would you believe me if I told you that all the things that we like, what we have just seen, I failed in high school.
Really? Why?
Yes.
If it's not an uncomfortable question for me to ask about you.
I didn't understand it, and now in what we have of class, I understand it perfectly.
Well, let's take this as a. I don't think you guys would mind if this is still being recorded. May I shut down the PowerPoint and ask you guys to turn on your cameras, please, for a moment, so we can chat? Please? Please turn on your cameras. Let's chat a little bit here. So please turn on your cameras. Thank you. Let's chat here for Paulina Clemente, please put your correct username in your Zoom before I finish counting down to 0 from 5 very slowly, or I'm going to have to put you in the waiting room. And Marco, please turn on your camera. Same time frame. So 5, 4, 3, 2, 1. Okay. Sorry about that. We do have to follow some rules. Okay. Let me take a moment to chat with you guys. First off, Daniel, thank you for sharing. Okay, thank you for sharing. I'd like to share with you guys, taking Daniel's comment. I want to share some things with you guys, and this is kind of like what I like to call a sort of a mentoring moment. Okay, these are the sort of things people who know me, students who know me, know about this. These are what I call the SOSA mentoring moments. Aime, go ahead.
Teacher, I was actually here. I just didn't hear it. I couldn't hear the computer since everybody's using the same, like they're using different computers. My audio was muted, but I was actually, I'm in the classroom.
Okay, yeah, but there were two situations here. So I can't see your face. You seem like you're going to you're going to hijack me. So is it Marco?
Yeah, it's Marco, teacher.
Okay, log in again, and I'll let you in because there was.
I'm in the waiting room.
Okay, I'll let you in. And there was somebody called Paulina, and I have no Paulina.
Paulina Clemente is Arturo Clemente, and he was changing his name, but he didn't answer. He was changing it.
Okay, tell him that as soon as Arturo Clemente appears, I'm going to let him in from the waiting room. Okay. And so please just no worries. Please turn on your camera, Marco, as well. So these are the people who know me. These are what I like to call what I like to call SOSA mentoring moments that are unrequested and are not necessarily part of the course. But I'm going to ask Fernanda. Fernanda, do you know what's going to be really cool of whatever I'm going to be whenever I take a pause and give you guys some mentoring and some advice that doesn't have to do with math? Do you know what's really cool about that, Fernanda? What do you think is really cool about that? Whatever comes to mind, Fernanda.
Can you repeat the question, teacher?
I'm gonna be giving you some advice, some mentoring in different parts of the semester where I'm going to take a pause and talk about things that aren't necessarily having to do with math. What do you think is going to be good about that? By the way, I have no idea is a valid answer.
I don't know.
Perfect. That's not bad if you answer I don't know. Okay. What's cool about these moments is that they're free. Okay. What does that mean? Whatever I tell you, you can be paying attention, you can not be paying attention, you can be doing whatever you want. But trust me, if you pay attention and kind of think about some of the things I'm going to be telling you and recommending, I'm 99.9% sure that it's going to help you out moving forward as engineering students and as engineering professionals. Okay. I literally still have students that contact me that are not students, that are alumni, just to ask for advice about things. Okay. And I think they do that because some of the advice has been helpful. But you can do whatever you want with the advice. Okay. You can do whatever you want with the advice in the mention. Okay. So either pay attention or go to your happy place. This is for you guys. So thank you again, Daniel, for sharing. And I just want to put some context into some things. You guys are in university right now. Okay. And things are different. The game has changed in university. Things are going to be more complicated and you're going to be facing challenges. But you guys have grown and are going to be growing and developing. So Daniel, you shared with us that when you were in high school, you saw some of these topics and they were difficult and you flunked them. And now you're understanding them a little bit better. I'm going to say that that's not because you're taking my class. That's because of you. You've grown since you first took these to now. You're in a different mindset. I'd like to think that you guys are here in engineering because you want to be, not because you're forced to be. When we were in high school, and I was also in high school as well, would you agree that how many courses did you guys take in high school, Alejandro? How many courses did you take roughly each semester?
Like 8 or 9.
Maybe
Maybe
8, 9,
10.
sometimes 10. Did you
Yes.
choose any of these courses, or were these courses there because the academic program you chose that? No, there was these are the courses you have to take, and there were 8 to 10 courses. How many courses are you taking now, Alfredo, this semester?
5.
5. You're taking half of the amount of courses, and that's great. It's half the workload. Actually, no, it's double the workload because these courses are going to be more challenging. But you're taking these 5 courses because you want to study industrial engineering. And that's a big difference. And you guys are in a different mindset. And ideally, you've grown from being in high school to being here. Okay. So I would say, Daniel, that you should be noticing that some things that were kind of like blurry or murky when you were in high school, now they're going to start to be a little bit more clear. In part because we're trying to do a good job to try to explain them, but also because you're in a different mindset. Okay. I'm gonna tell you guys something that's gonna be very harsh, but I'm telling it to you guys because it's true. Okay. If I had $1 for each engineering student that struggled with math and programming in their first and second semester and even flunked them and thought that they were not going to be able to be engineers, and right now are extremely successful engineers, either in very important positions in their companies, or doing a master's degree or even doctoral degrees, and being very successful in engineers, if I had $1 for each of those situations, I could probably retire right now. Okay. And I don't want to say names because actually I don't want to, like we would say in Spanish, burn any people, but I could give you names of a bunch of engineers that you're probably going to interact with if you do internships, that you would be amazed. You're going to be at Honeywell, at Skyworks, that a lot of companies, and you're going to be interacting with engineers that are out of SETIs, and you're going to go, oh, this guy, wow, this guy is the director of engineering. He's been in charge of a bunch of stuff. Wow. If we could talk the professors about how maybe some of these people struggled at the beginning with math and physics and programming, you would be amazed. Okay. The idea or the problem isn't for you to struggle. It's for you to overcome the struggle. Does that make sense to anybody? Does that make sense? To overcome the struggle. I joke with some of my colleagues and even with my wife that you guys would probably not have survived engineering when I was in school. I had a professor that gave us physics 1, 2, and 3 in engineering. I never passed any of his exams. And I ended up being a straight A student. But I learned a lot. And that's what I want to transmit. I'm very glad to hear that, Daniel, that now you're understanding some stuff, but that's because of you. And I hope that sort of epiphany happens for the rest of you, okay? Because right now you're in engineering and things have gotten more interesting, okay? I'm going to throw this out there. How many of you, I don't think many of you are struggling with the math course because this is not necessarily I would say a course where you're seeing anything different, but how many of you are struggling with programming? None of you are struggling with programming. It's extremely easy. Oh, that's good to know. My intuition was probably incorrect then. Yeah, struggling with programming is normal for a first semester engineering student. The thing is that you've got to overcome it, and you're going to overcome it. Luis Gallardo, I think you raised your hand because you were being frank and because of programming, or did you want to ask something? Yeah, okay. So the thing is, if you're struggling,
it was because I'm kind of struggling, that's why.
And that's normal. That's normal. If you're struggling, you need to get help. Okay. The idea is for you to get help, all of you to get help and get through it. And if you're struggling with these things, that doesn't mean you're not going to be a good engineer or that you can't be an engineer. It just means that engineering is tough. Okay. And that's part of the trials by fire that you all have to go through. Okay. Are we in sync right now with all of that? Okay, good. Anybody want to make thank you again, Daniel, for sharing. Anybody want to make a comment or ask something? Okay, now I'm going to take a pause because I'm going to switch over a little bit more to what we were talking about here in the course. We were talking about functions, right? We're talking about functions, and we're going to start talking about graphing functions. And again, that's kind of like magic. Okay, so what used to happen before the pandemic? We used to have parties, right? We used to have parties, and we got together and we chatted, and we maybe, if you're over a certain age, you maybe had a drink and had food, and maybe there were people at the parties that there was somebody I liked at the party, right? And I kind of wanted to get close to that person I liked, but I didn't. I for example, I struggled with kind of talking to people, and I'm very introverted. And so getting to talk to somebody you like, there's some of you that's probably very easy for you, right? There's some of you that are probably really cool with that and are very easy, but maybe there are some of you that struggle with that, okay? Well, graphing functions may get you for that person to be interested. Have you ever thought about that? So you're at a party and you want to kind of talk to somebody that you don't know because you like them. So you kind of get close to them and you're kind of scribbling down a function, and then you just say to them, oh, look at this function. And they're going to be like, wow, that's a very odd function. And you're going to tell them, can you graph that function? 99% probability that they can't. And they're going to say, no, that's a very difficult function to graph. That's really difficult. And then you're going to say, well, you know what? I can graph it. And you're going to graph the function. And they're going to be like, whoa, really? Really? No, that was a trick. That was a trick. You already knew the function. Then you're going to tell that person, give me any function, any function. And all right, they're going to say, graph this. And you're going to say, give me a moment. And you're going to show them that. Wow, give me another function. And you're going to be graphing the function. And this person is going to be like, wow, this person is so interesting. I want to get to know this person. I might even want to marry this person because this person can graph any function that I can give them. And this is another tip. This is what I call the wise silence. Okay. And we're gonna do this. We're gonna do this exercise. I'm gonna choose somebody here. Which I'm gonna choose you, Mark. Okay. You're talking to the person. You're gonna follow my lead and what I'm gonna say. Okay.
Teacher, can you hear me? I don't know. Like a couple of seconds ago, it said my intellectual is unstable. Is it stable now? Can you hear me correct?
I can hear you. I can hear. There's a little bit of echo because you're in the classroom, but I can hear you perfectly. So just unmute quickly for the. So you're talking with the person, and this person is really amazed because you can graph any function, and then you're gonna tell them. The person is gonna ask you something. The person is gonna ask you, well, what are you studying, and what are you gonna answer, Mark?
Industrial engineering at the global program in CETIS.
And they're gonna be like, wow, really? Wow, this points for this person. Wow. And then follow my lead, Marco. Then they're gonna ask the following. Wow, that must be really difficult. Follow my lead. You're gonna do this, Marco. When they ask, that's probably really difficult. You're gonna do, no, you're not gonna answer. You're not gonna answer. You're gonna do this. they're gonna say, this is, excuse me? Okay, I'm gonna mute you a little bit. There's a little bit of echo there, okay? But I think you can hear me, right, Marco?
Yeah, I can hear.
Okay, so don't say anything, just do this. When the person asks, that's probably really difficult, right? You're gonna do this. Can you do that, Marco? Oh, so wow, that must be really, you're studying industrial engineering global pro, that must be really difficult. What are you gonna do, Marco? And then after that, the next question is gonna be, wow, you must be really smart. You're gonna do exactly the same thing you did for the previous answer. So again, so you must be really smart. What are you gonna do, Marco? And after that, you're like, oh, well, would you like, and then you're gonna say, would you like to, I don't know, let's go to the movies, let's go have an ice cream. And after that, you just start planning the wedding, okay? And everything works out. Is that clear to everybody? These are tools not only for engineering, these are tools for life, okay? Is that clear to everybody? Have you written down in your mind the rules for the party that you're gonna be doing? After this unit, you are going to be able to do that, okay? So let's see if this was clear. Somebody I haven't asked, I think I've asked everybody now, but let's do an exercise. Leo, I think I haven't asked you, Leo. Let's do that exercise again, Leo. So, wow. What are you, so this is amazing. What are you studying?
Industrial engineering.
Global program at CETIS University.
Industrial engineering global program.
At CETIS University.
At CETIS University.
Wow. So that must be really difficult, right? Good job. Good job. Oh, wow. And you must be really, really smart, right? Perfect. Leo got it down. Leo got it down pat. You should talk to Leo. He's got the reactions down perfectly. Remember that and thank me when the wedding occurs. You don't have to invite me to the wedding. Just send me a note and tell me it worked. Okay, it worked. Okay, I'm going to switch over to the PowerPoint. This was just kind of a mentoring moment. Okay, so we're going to be talking about graphs, and we're going to be able to graph anything, literally, just knowing some information about the. I'm sorry, just extracting. I'm sorry about that. Just extracting some information about the function. And so one of the important things about a function or information about the function is the intercepts. So the intercepts are going to be points where the function crosses either the x or the y point. Okay, and these are going to be we call them the x-intercepts and the y-intercepts, and they're going to be basically points where the graph crosses either of the axes. There's another thing that's important to differentiate between what is a function and what's not a function, and it's called the vertical line test. There are some exercises in homework task 6 that have to do with this. So if I give you a graph, and like any of the 3 graphs that we see there, and we draw vertical lines across the graph, the vertical lines should only intersect the graph in one point. If that occurs at any moment, if that occurs, this is a function. However, if I draw a vertical line and the vertical line intersects in more than one point, this is not a function. Over here in this one, for example, I'm drawing a line here and it intersects in more than one point. So if I get, because we're going to be looking at functions in 2 ways. We're going to be looking at functions as a mathematical expression, but we're also going to be looking at the functions in, in graphs and plots. So if we're looking at them in a graph, the vertical line test helps us identify if it's a function or not. If the line interacts in only one point, then that means that the function is, the graph is a function. If it intersects in more than one point, it is not a function. Okay. Now let's look at this. This is the same function we had already done before. We had already identified this one before. We had already done it. And we want to kind of sketch the graph for this one. And so some of the things we had already identified here. The domain, we had already seen it. It was going to be, it was from 3 to infinite. The intercepts with the y-axis, these are going to be points where x equals 0, okay? So what happens when x equals 0? If I substitute x equals 0 here, I get y equals 4 plus the square root of -3. This is not valid. This does not exist. This is not a real number. So what does it mean when that happens? It means that there are no intercepts in the y-axis. What does this mean? It means that the graph does not cross the y-axis. It will never cross the y-axis. The intercepts with the x-axis occur when y equals 0, okay? So this means that 0 equals 4 plus the square root of x minus 3. This would mean that -4 equals the square root of x minus 3. And guess what? That cannot happen as well. This is not valid because the square root is never going to be negative. This means that the graph does not cross the x-axis. So that means that the graph, however it is, it's floating somewhere. It means it's not crossing the x-axis. Now, if we had already done this as well, we had already identified the domain and we had identified the range. The range was going to be from 4 to infinite. That means that when x increases, y increases as well, okay? If x goes from 3 to infinite, y is going to go from 4 to infinite. That means that the graph is going to be growing, okay? For any of the values of the domain. Let's look at how that graph would look. Oops, I have that slide hidden. Give me a moment. Here, that slide is hidden. Here we go. Let's look at how this slide would look. I'm sorry, let's look at how this graph would look. There we go. Okay. So if we were to graph this, first off, the domain is going to be from 3 to infinite. And the range is going to be from 4 to infinite. The reference point is that for x equals 3, y equals 4. So this is going to be the reference point. And we just said that when x increases, y increases as well. So somehow the graph is going to be growing, is going from this point onwards. And it's going to keep growing until infinite. Now, right now, we just did this graph using the information of the x the domain and the range and the X and Y intercepts. We're going to be seeing, so this isn't going to get you married. Yeah. However, we're going to be seeing some other additional tricks and tips to be able to do the plot and the graph with a little bit more precision. And that is going to have to do with certain models of functions. And we're going to see that in the next topic. What we're going to do now is that we're going to practice before we leave. We're going to practice finding the intercepts. Okay. And so let's look at these two functions here. We're going to find the Y and the X intercepts. So first off, for X equals 0, Y is going to equal 0 squared plus 2 times 0 minus 2 is going to equal minus 2. So the intercept in the y-axis is going to be 0, comma, minus 2. And then for y equals 0, we're going to have 0 equals x squared plus 2x minus 2, or x squared plus 2x minus 2 equal to 0. Can somebody help out finding what can we see with regards to the roots of that polynomial? We could use the general formula if we wanted to. I believe that we can't factor that one directly. We're not going to be able to factor that directly. So if we use the general formula here for this one, and you can help calculate that as well, X is going to be, remembering the general formula is minus B plus minus the square root of B squared minus 4AC divided by 2A, where A, B, and C are going to be the coefficients of the trinomial. This is going to be X equals minus 2 plus minus the square root of 4 minus 4 times 1 times minus 2. This is going to be equal to 8 divided by 2 times 1 is 2. This is going to be equal to minus 2 plus minus the square root of 4 plus 8 is 12 divided by 2. We can, let me draw this a little bit more to the side. X equals minus 2 plus minus the square root of 12 divided by 2. This is going to be equal to minus 2 plus minus the square root of 12 is the same as the square root of 3 times 4, and the square root of 4 is 2. So this is going to be 2 times the square root of 3 divided by 2. The 2's are going to be eliminated. And so the roots are going to be minus 1 plus minus the square root of 3. So this would mean that the intercepts are going to be in -1 plus square root of 3 comma 0. Going to be in -1 plus square root of 3 comma 0. And -1 minus square root of 3 comma 0. That's the way we find the intercepts. Daniel, go ahead, please. Sorry, I didn't see your hand.
That's where the parabola hits the X line.
Correct. That's a good observation. So if we were to graph this, if we were to do a quick graph of this, going back to the plotting there, it would mean that the parabola would be something like this. This point here would be the -2, and these 2 points here would be these two. Okay.
But isn't the midpoint of the parabola not 0? It's like, wouldn't it be like a little bit, I don't know if it's either to the left or to the right?
Well, actually no, because the intercept is, yes, I didn't draw it. This isn't drawn to scale. This is just kind of a sketch. This is kind of a sketch. So what would be happening here is that we haven't found the vertices yet. So right now, the only thing we're doing is locating the points where it crosses the X and Y axis. And we know it's a parabola. That's kind of like a spoiler. We know that it's square root. So we know it's a parabola. So we know it has kind of that U value. If we wanted to make that more precise and know where the lowest point is, we would need to calculate the vertices. And we're going to see that a little bit further on. Right now, that's kind of just like a sketch. We don't really know if it's centered in 0, -2 yet. Okay. So right now, the only thing we're doing is finding the intercepts. Okay. Lastly, before we go, for this one over here, for X equals 0, we would have Y equals 0 squared minus 2 times 0 minus 3, but we're dividing by 0. And remember that that cannot happen. So this is invalid, and that means we have no intercepts because that's not a valid value. For Y equals 0, we would have 0 equals X squared minus 2X minus 3 divided by X. We are really only interested in the numerator, because the numerator is the one that's going to make the quotient 0 because the denominator cannot be 0. So that would mean that this turns into X squared minus 2X minus 3 equals 0. And if I'm not mistaken, this can be factored into X. Write this down a little bit. X squared minus 2X minus 3 equals 0. And if I'm not mistaken, this can be factored into X minus 3 and X plus 1. That would mean that the two intercepts would be at X equals 3 and at x equals -1. That would mean that the two intercepts for this one would be in 3, 0 and -1, 0. So the only thing we're doing right now is, again, finding the intercepts. I'm just going to draw a line here to separate this one. Okay. And the only thing we're doing there is finding the intercepts. I'm going to take a screenshot here. This. Okay. Okay. Now, before we leave, I'm gonna upload this video in a few moments before we leave, because I know you've got Spanish. Oops. Workshop number 5 that has to do with homework task number 6. Remember, homework task number 6 is for next Tuesday, next week, I believe. No, homework task number 6 is already in Blackboard. And let me just quickly check the date there. It's for, somebody said something?
Yes, October 5th.
October 5th. So that it's for next it's for next week, October 5th. And it's some of these problems here that we're looking at. And so workshop number 5, each of your houses has 3 problems from homework task 6. Please work on these and have them ready by Thursday. And we're going to start reviewing them on Thursday. Okay, it's just 3 problems. And if you have any questions, let me know. Okay, these are for Thursday. For next Thursday, have them ready to present. If you get stuck on anything, then let me know, send me a WhatsApp. And remember that we're going to review these in class. Okay, for next Thursday of this week. Okay, and remember that you've got tutoring with Estrella if you need that. Okay, okie dokie.